excavating out dirt and rock, and then lining the tunnels. Then, to get the water to go into those tunnels, they took a lot of that excavated dirt and rock, and they dumped it in the upper part of the river to create a smaller dam called the cofferdam. The upper cofferdam diverted the river water coming down to go into the tunnels and come out the lower end, while they put in a lower cofferdam just to prevent water from backing up into that construction site, which was about a half-mile in length. So with those two smaller dams in place, they still had to continue digging and scraping away all the extra water and mud and dirt and rock and loose debris until they hit a hard, solid bedrock foundation for the base of the dam, which turned out to be down another 135 feet until they hit that bedrock. Then they brought even more work crews in, and we're talking 1930s Depression era. These crews worked diligently, round the clock, with only 2 days off a year. They were lowering huge buckets filled with 8 cubic yards of concrete. That's about as much to fill up an entire cement truck like you see on the roads. Lowering them down by cableways from the top of the canyon walls down into wood box platforms that they had built to keep building up the dam. At the height of construction, they timed it where those giant buckets were coming down every 78 seconds, 24 hours a day, 7 days a week, nonstop. I'm not even sure how they did it with only 2 days off a year, but they did and came in ahead of schedule. So the structure of the dam was completed just shy of 2 years. But before it was done, they closed off 3 of the tunnels with huge steel gates and concrete tunnel plugs, and that allowed water to start filling up behind the dam to create Lake Mead, while one tunnel was left open to keep water flowing down the Colorado River. They built intake towers and they put them higher up on rock ledges on the sides. So once the water level hit the bottom of those towers and had somewhere to go, then they closed off that last tunnel like they did the first 3, and they blew out the lower cofferdam so that the water could funnel through and go downstream. Now by that time, the upper cofferdam was already underwater, and it is still intact underneath the water of the lake today. Sort of like a big 98-foot hump that's deep beneath the surface. So now we have water goes into our intake towers. There's 2 on the Nevada side and 2 towers on the Arizona side. Water goes into the towers and then travels down into 30-foot diameter penstock pipes, exactly like the giant pipe that you see right outside the window there. 30 feet in diameter. You're looking at it from the top, but it's pretty big. And if you feel all that vibration rumbling in your feet right now, that's water that is running through that pipe at this moment. At times it will go even harder, and it goes up to 96,000 gallons a second, which is enough to fill an Olympic-sized swimming pool in less than 7 seconds. So from the big pipes, if we're talking the smaller pipes that go beneath our power plant floor, those taper off and get even more narrow. That increases the pressure and the water velocity. And it comes in and hits the big turbines that are deep beneath the giant generators to start spinning. And then the water goes downstream when it starts that hydroelectric process. We're going to go over to the power plant in just a couple of minutes so you can see those giant generators. But before we do, I'm just going to point out our 2 spillways. There's one on the Nevada side and another on the Arizona side. Spillways are very important for any dam because you never want to take a chance that water could ever flood over the top of the dam. Right on the curve up on top there, that's our roadway up above. You probably saw it when you came in, cars driving on it, people walking on it. So floodwater would not only damage that, but it would do severe damage to the power plant down below. So those spillways on the sides are 27 feet lower than the top of the dam, and there's gates along the sides of those which also control any water which may ever arise. So water goes down into the spillways, and then it drains out into other tunnels that were built over those tunnel plugs and uses the old diversion tunnel to go downstream, and we never have to worry about flooding. So far in Hoover Dam history, those spillways have only been used twice. The first time was in 1941 when the lake was first built, and the second time was a flood emergency we had in 1983. A lot of rain and snow that year, and the snowmelt coming down from the Rocky Mountains, the Continental Divide, came down to Colorado so that not only some of those upper basin states were flooded, but the level of Lake Mead rose to just 7 feet below the top of the dam, as you can see in this picture. So that little wall back there, that's actually the top of the dam from the backside, and then those are the intake towers, and then of course water just gushing down into the spillways. As a local, it was huge news and a sight to see at that time because it ran continuously for 63 days straight with the floodwaters coming down, and the pressure going over the side was so hard, the spray coming back up, and water coming out of the base of the tunnels. I tell people I think it was better than any water show you can see at the Bellagio in Vegas. And also because somebody had the nerve to ask me this once. I saw it in 1983, not 1941, because I am not that old. Okay, so I'm going to be leaving you guys back. Nobody leave the room yet. I'm going to lead you back. We're going over the elevator to go up to the power plant next. Just make sure you stay walk out with your immediate family and friends because we're going to take use 2 elevators again. But if you do get separated, don't panic because it's a short trip and we're going to all end up with a